Lesson 4-8. Use isosceles and equilateral triangles. By the end of today's lesson, we will be able to successfully use theorems about isosceles and equilateral triangles. So let's first review some vocab terms. The legs of an isosceles triangle are the two congruent sides. So if this was an isosceles triangle, these would be the two legs. And then we have the vertex angle of an isosceles triangle. And it is formed by the legs. So it will be this angle. And then we have the base of an isosceles triangle. And the base of the isosceles triangle is the side that is not a leg. So we're talking about this one. And then we have the base angles of an isosceles triangle. And they are the two angles adjacent to the base. So it will be these two angles. So it is highly important that you know how to describe these parts of an isosceles triangle, because later when you do proofs involving isosceles triangles and I ask you to write a paragraph, then these will be the descriptions that I would like to see in your paragraph. Okay, in theorem 4.7, we have the base angles theorem. And it states that if two sides of a triangle are congruent, so we have a picture here, if these two sides, AB and AC, are congruent, then the angles opposite them are congruent. So we can say angle B is congruent to angle C. And then we have the converse of base angles theorem, which is just the opposite. Meaning if two angles of a triangle are congruent, we're talking about angle B and angle C here, then the sides opposite them, AC, will be congruent to AB. So these are the opposites. Okay, example 1 here. In triangle FGH, FH is congruent to GH. Name two congruent angles. So it will be angle F and angle G, because they are the angles opposite these two sides. So we can just write angle G is congruent to angle F. Okay, then we have the corollary to the base angles theorem, and it states that if a triangle is equilateral, then it is equiangular. Equiangular. And the corollary to the converse of the base angles theorem states that if a triangle is equiangular, then it is equilateral. So we can rewrite this as a biconditional. The corollaries state that a triangle is equilateral if and only if it is equiangular. Example 2, find the measures of angle R, S, and T. Well, since all three sides are congruent, then they are equiangular by the corollary to the base angles theorem. So they're equilateral, then therefore they're equiangular. And we can just take 180 degrees and divide by 3. And each angle will be 60 degrees. And example 3, find the values of x and y in the diagram. Well, because triangle JKL is equiangular by these marks here, then this means by the corollary to the converse of base angles theorem, we can say that all these sides are congruent, so x has to be 8. Because it's 8 here, so this has to be 8, and this is also 8. And then because angle M is congruent to angle J by these little arcs, double arc here, then by the converse of base angles theorem, ML has to be congruent to JL, and since x equals to 8, we could set it equal to 2y, so y equals to 4. Example 4. The pattern at the left is present in a quote. A. Explain why triangle ADC is equilateral. Okay, first, we notice that AD and side CD are congruent to each other. So by the converse of the base angles theorem, we can say angle DAC is congruent to angle DCA. So I'm talking about this angle and this angle. So triangle ADC is equiangular. And when triangle is equiangular, by the corollary, to the converse of base angles theorem, we can say that triangle ACD is also equilateral. So it's quite obvious, but if I ask you to use these theorems to explain, make sure you understand how to apply them. Now, part B asks you to show that triangle CBA is congruent to triangle ADC. Now, by the base angles theorem, angle ABC, so angle ABC is congruent to angle ACB. So ACB, so that because these two sides, side AB and AC, are congruent to each other, then angle ABC is congruent to angle ACB. By the base angles theorem. And then therefore, triangle CBA is congruent to triangle ADC by angle side congruence. So we have, so these two angles are congruent. So angle, side, angle, side. So that's one way to prove it. Now example 5. If side FH is congruent to side FJ, then angle H is congruent to angle J by the base angles theorem. If triangle FGK, so this one, is equiangular, so I'm going to mark this, and FG is 15, then GK would also be 15, so that's very straightforward. So example 4 would be something that I would like you to pay more attention to. Okay, that's it.